Hello my dear students, I hope you all are fine and very much healthy. Okay, now I'll proceed with exercise 2.5. If I go forward, actually some part of this exercise I have already explained you. The first part is basically when we do it, solve these quadratic equations by formula method. The formula that we use is x is equal to, if x is the variable of the quadratic equation, then x is equal to minus b plus minus root b square minus 4ac upon 2a. This is the actual equation. Okay, I hope you know what is a. A is the coefficient of x square, b is the coefficient of x, and c is the constant. Here basically this term b square minus 4ac is called as the discriminant, which at times is denoted by this triangle, small triangle. This is called as discriminant. And why it is called as discriminant? Because it discriminates the quadratic equation. How, in what way? See, when we find the value of discriminant, this basically b square minus 4ac, when we solve, we substitute the value of b over here, substitute the value of a and c, and find the value of b square minus 4ac. If this discriminant is greater than 0, means all positive numbers, then we can say that nature of roots of this given equation is real and unequal. I hope I have explained you this, that basically the roots will be real numbers, they will be existing numbers, and the two roots, usually we have two roots, both the roots will be different roots. Okay, and if discriminant is exactly equal to 0, then nature of roots of given equation, of given quadratic equation will be what? It is exactly equal to 0. The roots will definitely be real, they will be existing, and they will be equal and equal. In 7, 7, 3 upon 4, 3 upon 4. Two roots will be there, and both the roots will be having same value. Okay, and if the discriminant is less than 0, means negative number, then the roots don't exist. The roots are non-real or not real numbers. The roots don't exist. Okay, my dear student, that is this. In this way, the value of this b square minus 4ac will be discriminating the roots, and that's why this is called as discriminant. Now what later is that? What was it? Anything else I was put to say? No. Okay, the reason why it is like that is basically, see, when a positive value of a is there inside the radical, the square root of a positive number is definitely possible. That's why we have two different numbers, and you take the square root of any positive number, let it be 16, the answer will be plus or minus 4. Two values will be there, plus 4, minus 4, and because of that we will be getting two different roots. Of course, after in this equation, when we solve this equation, we will be getting two different roots. And if we have a 0, so definitely the 0 will be, the square root of the 0 will be 0, and then eventually you will have only one value, and but still you will have to specify it as two different roots having same value. And but when the radical is less than 0, means there is a negative number inside the radical. Remember, square root of negative number is not possible. We can't have a square root of a negative number. Okay, so that is the reason when the discriminant is less than 0, then we say that these are non-real numbers. This is a non-real number. This number actually doesn't exist. Okay, my dear student. So with this, actually one topic is that I just brushed up with the topic. I have explained this topic previously also. Now the next is that you have to understand is, supposing if there is an equation ax square plus bx plus c is equal to 0. This is the quadratic equation. As we know that quadratic equation has roots, means those value which when you substitute in the place of x, then this whole equation will turn out to be a 0. They are called as roots. Now if we consider that alpha and beta are the roots, some values which we normally get after solving the quadratic equation, we get a value of the root. So if these values can be anything else. Now why I have taken alpha and beta? See, very simple. Actually speaking, this would have been anything. This could have been y, this could have been m, this could have been n, this could have been anything. But problem is that your quadratic equation sometimes can be in the form of y. Quadratic equation sometimes can be formed in the form of m, t, s. It can be anything. So at that time, these roots, the variable of these roots should not confuse with the variables used over here. So that's why we have taken the variables of the roots as entirely some different root, not from the alphabets of the English alphabets, and that's why we have taken it to be alpha, beta. Usually we don't use these as the variable. Normally they are not used. So that's why alpha and beta are, but remember they are the roots of given quadratic equation. Okay, now what next? Now see, this alpha and beta, they have a different relationship with the quadratic equation. And what is the relationship? Sum of the roots. What is the sum of the roots? Alpha plus beta. I can definitely directly find the sum of the roots. If I have got any quadratic equation, I can directly find, I may not directly find the roots, sorry, but I'll definitely find the sum of the roots. And what is that? It is equal to minus b upon a. Means whatever is the coefficient of x, formula minus, this is minus of the formula. If this is plus, then this will be minus b upon a, whatever it is. The formula is minus b upon a. Okay, and alpha into beta means the product of the root is equal to c upon a. See my dear student, this is definitely something different that you are understanding, and the purpose of this will be totally different. Let me take one example for you people to maybe understand somewhat in a better way. Do I have an example? Of course, plenty of examples are there. I want something better. But without finding something better, you always end up. Okay. Now I have perfect. Now let us take a look at these examples. See here, one is that I'll just run through, but 2y square plus 27y, 2y square plus 27y plus 13 is equal to 0. Okay, this is one quadratic equation. Now if I have this quadratic equation, I can find alpha and beta. Alpha and beta will be the roots. So what will be the roots? Supposing I go to solve this, of course I will have to find the product of the roots. So I hope that you all are now very champion in this. 26 1 are 26. So what I'll do is 20y square plus 26y plus 1y plus 13 is equal to 0. I hope now you know how the splitting of the middle term is there and what it is all about. 2y will go outside, y plus 13. Here there is no common factor, so 1 will go outside, y plus 13. This is still equal to 0, and y plus 13 into 2y plus 1 is equal to 0. Now y plus 13 is equal to 0, or 2y plus 1 is equal to 0. So you will get y is equal to minus 13, or y is equal to minus 1 upon 2. Okay, these are the roots. Now that means what? Here alpha is equal to minus 13 and beta is equal to minus 1 upon That is what we have got. Now, if supposing if I have to add these roots, sum of roots will be equal to what? Minus 13 plus minus half. So if I go to solve this, minus 13 minus half, this will be minus 26 minus 1 upon 2. This will be minus 27 upon 2 will be the sum of the roots. And what about the product of the roots? Product means multiplication, minus 13 into minus half. The minus minus will give me plus 13 upon 2 is the product of the roots. This is the product of the roots and this is the sum of the roots. Now see, if instead of going by this fashion, sum of the roots and product of the roots, if I would have known, if I don't even want to find the roots, just I want to find the sum of the roots, then what will I do over here? Sum of the roots, I don't know what they are. What are the roots? I don't know. But by formula I know it is equal to minus b upon a. So that will be equal to, now minus of the formula, b is 27, a is 2. That's all. This is the sum of the roots. I have not, even now I don't know what are the roots. I don't know what are the roots, but I can directly get the value of sum of the roots. And what are the product of the roots? I don't know what are the roots. The product of the root, the formula is c upon a. C is 13 upon a is 2. Now check this. If I would have found the value of the roots, see, the sum of the roots would have been minus 27 upon 2 and the sum of product of the roots would have been 13 upon 2. If in case we don't need to find roots and we need to find only directly the sum of the roots, this is basically giving you the relation between the general equation and the sum of the roots, general equation and the product of the roots. Roots definitely have a relation. Roots have a relation in different ways. While finding the factorization, you can find the by the method of factorization you can find the roots. By the method of formula you can find the roots. So roots definitely have relationship with the quadratic equation. But apart from that, sum of the roots and the product of the roots also have relation with the quadratic equation. Sum of the roots is equal to minus b upon a, product of the roots is equal to c upon a. One more thing, my dear student. Now supposing if this is I am having one more thing. Now this is entirely different. Now I am going reverse way. Supposing if I know sum of the roots, sum of the roots is minus 27 upon 2, product of roots is 13 upon 2. Okay, see my dear students, if I know the sum of the roots and I know the product of the roots, I don't know the equation. I can frame the equation. See my dear students, what I am trying to explain you is, before this quadratic equation was given to you, when quadratic equation is given to you, you could find the roots. Now where are we? If supposing we know the roots, if we know the roots, then can we frame the quadratic equation? Yes, we can frame the quadratic equation because sum of the roots and product of the roots have link with the quadratic equation. When the root is given, first I will add the two roots and find the sum of them. When the roots are given, first I will multiply the roots and find the product of them. And once I get the sum of the roots and the product of the roots, now the formula is, equation is of the form x square minus sum of roots into x plus c, the constant, plus product of roots, plus product of roots is equal to 0. I'll come, this we will do in detail, don't worry about that. The formula is what? X square minus sum of roots into x plus product of roots is equal to 0. Remember, this is always minus and this is always plus. Now can I go back to the equation? See here, it will become what? X square minus sum of the roots. What is sum of roots? Minus 27 upon 2 x plus what is product of the roots? 13 upon 2 is equal to 0. Now if I solve this, what will I get? Minus minus plus 27x upon 2 plus 13 upon 2 is equal to 0. Now I will multiply throughout by 2 because I don't want these denominators. 2x square plus 27x, 2 and 2 will get cancelled, plus 13 is equal to 0. This is your equation. See, 2y square. Okay, here it is in the term of y. 2x square plus 27x plus 13 is equal to 0. So what am I trying to explain is that sometimes what will happen, means many number of times that we have done till now, till x plus 2.4 we have been doing, quadratic equation is given to you, and from the quadratic equation you are finding the roots by the method of factorization method, splitting the middle term, or by the method of completing the whole square, or by the method of formula method. Okay, with this you will find the roots. Now we have to go reverse. If roots are provided to you, then can you frame the quadratic equations? Definitely you can. What you have to do, from the roots you have to find the sum of the roots and find the product of the roots. Once you find sum of the roots and the product of the roots, then by the formula, the quadratic equation is of the form x square minus sum of the roots x plus product of root is equal to 0. Substitute those sum of the roots and product of the roots over there. You will definitely go to the quadratic equation. Okay, you will be seeing some formulas over here, some problems over here, and then we will be able to solve this. Now let's come to exercise 2.5, question number 1. Activity is basically here what they are telling, quadratic equation ax square plus bx plus c is equal to 0, the quadratic equation, and then they are telling, now see, this is the quadratic equation, ax square plus bx plus c, and in one condition they are telling that there is a value of b square minus 4ac is actually equal to 5. Then what are the nature of the roots? Now this value b square minus 4ac is equal to 5. 5 means it is basically greater than 0, positive number. The nature of roots are going to be real and unequal because it is greater than 0. So real and unequal. In second case, what are they telling it? The b square minus 4ac is equal to minus 5. Now here if you will see, this is a negative number. Basically it is less than 0. Therefore the roots are not real, non-real number, not real numbers. Okay, this is what is going to be your answer. Fine. And in the second question, what are they asking you? This was first. Sum of roots is equal to minus 7. Sum of minus 7 and product of roots also they have given 5. Quadratic equation, we have to frame the quadratic equation. Now you know quadratic equation is what? Of type x square minus sum of roots, usually we write like this, alpha plus beta into x plus product of roots, alpha plus beta into alpha into beta is equal to 0. This will become x square minus of the formula alpha plus beta, sum of the roots is minus 7x plus alpha into beta, product of the roots is 5 is equal to 0. Now here if I solve this, x square minus minus plus 7x plus 5 is equal to 0. So the quadratic equation will be x square plus 7x plus 5 is equal to 0. This will be your quadratic equation. See this, I have got it like that. Okay. So now going to the third question. In the third question, what are they saying? If alpha beta are the roots of the quadratic equation, see now this is by alpha and beta are the roots. They are the roots of any quadratic equation. The equation they have given is 2x square minus 4x minus 3 is equal to 0. Then alpha plus beta is equal to what? Now alpha plus beta, you know by formula it is basically alpha plus beta. If by formula it is minus b upon a. Minus of the formula. What is the value of b? Minus 4. What is the value of a? 2. 2 2s are 4. Minus minus plus 2. So alpha plus beta will be equal to 2. Okay. And what about alpha into beta? When they ask you about alpha into beta, the formula for that is C upon A. What is the value of C? Minus 3. What is the value of A? 2. That is equal to minus 3 upon 2. This will be the value of that. So this is the way that you will be getting alpha plus beta is equal to 2. Alpha into beta is equal to minus 3 upon 2. Okay, my dear students, so with this we are finished with question number 1, and now we have to go to question number 2. This was I asked you all people to do for your homework. Find the value of discriminant. I just showed you all people that discriminant is basically b square minus 4ac only. Now remember, here they have only asked you to find the value of discriminant. They have not asked you to find the nature of the roots. Sometimes it is like determine the nature of the roots of the following quadratic equation. So basically, if the questions would have been this, still you will have to solve this. Okay, so x square plus, the first question is x square plus 7x minus 1 is equal to 0. So you will go with like this, comparing the given equation with the general form, that is ax square plus bx plus c is equal to 0. What is the value of a is equal to 1, b is equal to 7, and c is equal to minus 1. Fine. So discriminant, what is the formula of that? B square minus 4ac. What is b of what? 7 square minus of the formula 4 of the formula into a is 1 and into c will be again minus 1. Fine. So this will become 49. Minus minus plus 4 ones are 4. So this will become 53. Okay. 49 plus 4, that is equal to 53. Okay, fine, my dear student. So with this, now here what happens is that they have just asked you to find the value of the discriminant. But sometimes what will happen? Now supposing if the same question, it would have been this, determine the nature of the roots of the following quadratic equation. And instead of having this, if supposing this would have been the question. Are you getting my point? See, if supposing this question would have been over here. These all questions can be part of the third question. Okay. Find the determine the nature of the roots of the following quadratic equation, and this is asked. At that time, still you will have to find the discriminant. You will have to first find the discriminant, and here you will tell, since discriminant is greater than 0, therefore the roots are real and unequal. Okay. That will be the next part. We will be doing the third question. At that time, again, you will understand that. But I want to just make you notice that you have to actually think one step ahead. See, again, here I am going to find a discriminant. So here, comparing with the general form. What is the general form? Ax square plus bx plus c is equal to 0. What is a? 2. What is b? Minus 5. What is c? 10. Fine. So this is the general form, and now the discriminant. Formula for discriminant. Formula for discriminant is b square minus 4ac. If I substitute b is the value of minus 5, it is basically square. Minus 4 of the formula. Minus of the formula, 4 of the formula. A is 2 and c is 10. So what do I get over here? Square of a negative number is positive. This will become 25. Minus will stay minus. 4 2s are 8, 10s are 80. Now this is going to be 25, 35, 45, 55, 65, 75. And then 80. This is going to be minus 55. Okay, now this is the discriminant. Actually, if they ask you, this much is the discriminant and this is over. if now they would have asked what is the nature of the roots, then you would have further told b square minus 4ac is less than 0. It is a negative number. Therefore, the roots are not real. Okay. Now going to the third question. Root 2 x square plus 4x plus 2 root 2 is equal to 2 is equal to 0. Now again we will do the same thing, comparing with the general form. What is general form? Ax square plus bx plus c is equal to 0. What is a? Only root 2. What is b? 4. What is c? 2 root 2. These are the values. Now discriminant formula for that is b square minus 4ac. The b is basically 4 square, minus of the formula 4 of the formula, a is root 2 and c is 2 root 2. So this will become 4 square will become 16. This is minus. Now pay attention, 4 2s are 8. Okay, 4 2s are 8 and root 2 in root 2 will be 2. Right? 4 2s are 8. Root 2 into root 2 will be 2. 8 2s are 16. So this will become 0. Therefore, you will get the value of the discriminant is equal to 0. And here the nature of the roots would be real and equal because they are exactly equal to 0. I have told you this condition you have to remember, my dear students. This is very, very, very important. Somewhere in the exam you will be able to find this. Questions dependent on these type of ideas. Nature of roots. If discriminant is greater than 0, anywhere this you have to write. Exactly this you will have to write. Exactly this will have to write. Means discriminant, right? Discriminant over here. Since discriminant is less than 0, like this. Since discriminant is less than 0, therefore the roots are not real. Okay? Or the roots don't exist. Fine. This is we have completed with question number 2. Now let us move to question number 3. Here they have asked to determine the nature of the roots. Here they have asked you to determine the nature of the roots of the following quadratic equations. So what is the first quadratic equation they have given us? X square minus 4x plus 4 is equal to 0. Again, the first part will be the same, comparing with the general form. What is general form? A x square plus bx plus c is equal to 0. A is equal to 1, b is equal to minus 4, c is equal to plus 4. Now you will find the discriminant b is minus 4 square, minus of formula 4 of formula a is 1, c is 4. So therefore you will get b square minus 4ac. Minus 4 square of a negative number is positive 16, minus only 4 ones are 4, 4 ones are 16. So you get minus b square minus 4ac is equal to 0. This is what you have got. Now you will tell, since b square minus 4ac is less than 0, therefore is equal to 0, I'm sorry. Since b square minus 4ac is exactly equal to 0, therefore the roots are real and equal. That's all, my dear students. Hope you all are getting this. Now let's go to question number 2. This is second question. In second question they are given quadratic equation as 2y square minus 7y plus 2 is equal to 0. So what you will do over here? Comparing with the general form. What is general form? A y square plus by plus c is equal to 0. A is equal to 2, b is equal to minus 7, c is equal to 2. Fine, that is right. Yes. Now discriminant is equal to b square is minus 7 square minus of the formula 4 of the formula a is 2 and c is also 2. So here you will get square of a negative number is positive minus 4 to the 8 to the 16. This will give you 30. What am I doing? 3. Fine. Fine. So you will get b square minus 4ac is equal to 33. Now you can tell over here, since basically you can tell this is also, you can write it over here itself, so you don't have any problem. This you can put it in any way, my dear students. Since b square minus 4ac, now it is positive, na? Yes, greater than 0. It is positive, it is greater than 0. Therefore the roots are real and unequal. They will definitely be different roots. Here 0, real and equal. They are real and unequal because they are greater than 0. So question number 3, m square plus 2m plus 9 is equal to 0. Again the same thing, comparing with the general form. What is general form? am square plus bm plus c is equal to 0. You get a is equal to 1, b is equal to 2, c is equal to 9. Now definitely b square minus 4ac, b will be equal to, discriminant is equal to, b square is 2 square minus 4 of the formula, minus of the formula 4 of the formula, a is 1 and c is 9. What do you get over here? 2 2s are 4, minus 4 9s are 36. This is discriminant. Minus 32. Some thoughts are going in my brain, my dear student. So this is there. So now you will get, since discriminant is less than 0, therefore the roots are not real. They are non-real numbers. They don't exist. Okay, my dear student, with this we have finished question number 3 also. Now the question number 4, which actually is the basics that I have taught you today. Form the quadratic equation from the roots given below. As I told you, now till now what you have done is that a quadratic equation is given to you, and from the quadratic equation you are finding the roots. Sorry. Now in the fourth question what you are going to do is, roots are given to you. Form the quadratic equation from the roots given below. Form the quadratic equation from the roots given below. Now in first one, the roots are what? 0, 4. Now you will tell, let alpha and beta be the roots. Why you want to show this? Because you basically know, to frame the quadratic equation you will have to write sum of roots and product of roots. So you can't keep on writing sum of roots, product of roots, sum of roots, product of roots, and which root you are not sure. So now what? Alpha and beta are the roots. So you will tell alpha is equal to 0, beta is equal to 4. This is given. You have considered that one root is 0 and the other root is 4. Therefore alpha is 0 and beta is 4. Now you will be able to tell, now alpha plus beta. Now no need of writing sum of the roots. Sum of the roots, alpha plus beta, is equal to 0 plus 4 is equal to 4. Fine. And you will find product of the roots. No need of writing product of the roots. Alpha into beta is equal to 0 into 4, that is equal to 0. We know that the quadratic equation has a form, or is of a form. What is the form? Ax square no sorry, only x square. X square minus sum of the roots, remember this is sum of the roots, into x plus product of roots. Remember my dear student, these are product of roots. Okay, so now we will get x square minus sum of the roots is what? 4. Product of root is what? 0. Fine, so then the equation will be x square minus 4x is equal to 0. This will be your quadratic equation. Okay. Going to the second one. In second one, they are given the roots as 3 and minus 10. These are the roots. Again, you will tell the same thing. Let alpha and beta be the roots of given quadratic equation, where alpha is equal to 3, beta is equal to minus 10. This is basically given. Now we know that quadratic equation is a form. What is the form of quadratic equation? X square minus sum of the roots into x plus product of the roots is equal to 0. Remember, you are writing this, but always say sum of the roots into x plus product of the roots is equal to 0. So x square minus, what is the sum of the roots? Oh, I have not calculated that. Alpha plus beta is equal to 3 plus minus 10, that is equal to 3 minus 10 is equal to minus 7. This will be 1. And alpha into beta will be 3 into minus 10. That will be minus 30. This will be 2. Sorry, my dear student, this I should have done first. But it's okay. It's not that complicated and difficult. So please kindly adjust, my dear students. So alpha plus beta will be 3 minus 10 minus 7. That will be minus 7x plus alpha into beta will be minus 30. So you will get over here x square plus 7x minus 30 is equal to 0. Okay, this will be 6, 5, 10, 3. If you go by that, you will get the values definitely. Okay, so third equation, half and minus half. Again the same thing, let alpha and beta be the roots of given quadratic equation, where alpha is equal to half and beta is equal to minus half. This basically is given. You are only giving them a form. Now alpha plus half plus minus half, this is going to be 0 because half minus half will be 0. Alpha into beta will be half into minus half, that will be minus 1 upon 4. Fine, this is 1, this is 2. So now we know that the quadratic equation is of form. What is the form? X square minus sum of the roots into x plus product of the roots is equal to 0. So you will have x square minus sum of the root is 0x plus product of the root is minus 1 upon 4 is equal to 0. So this, if I open the bracket, this will be gone. Minus plus minus 1 upon 4 is equal to 0. And then you will have to multiply. Denominator normally we don't keep, so you will multiply throughout by 4. This will be gone. You will get 4x square minus 1 is equal to 0. You can keep it over here also, no problem, or you can take it over here also. Usually, but we don't keep the denominators. Now the next one is really very interesting one. Question number 4. In this question number 4, the roots are 2 minus root 5, 2 plus root 5. Don't get bothered about this. The more complex anything looks, the more easy it is. Okay, let alpha and beta be the roots of given quadratic equation. Therefore, alpha is equal to 2 minus root 5, beta is equal to 2 plus root 5. This is given. Now if I go to add the two roots, alpha plus beta, add this 2 minus root 5 plus, because addition it is, life is still very easy, root 5 minus root 5 plus root 5 gone. What stays is just 4. That's all. So easy. See, for tax this become such complex it was looking, and it became 4. Alpha into beta is equal to 2 minus root 5 into 2 plus root 5. Now only thing is that you should know a equation. You know that by identity, a minus b into a plus b. When the both are same, it is a square minus b square. A, b. The signs in middle, in between should be opposite. Then it is equal to a square minus b square. Here also 2 and 2, root 5 and root 5, both are same. Signs here in the middle are different, opposite. So this will be equal to 2 square minus root 5 square. This is 5 into beta. 2 square will be 4, minus root 5 square will be only 5. Okay, so this will be alpha into beta is equal to minus 1. Now we know that the quadratic equation is of form x square minus sum of the roots into x plus product of the root is equal to 0. So you will get x square minus sum of the root is 4, x plus product of the root is minus 1. So this will become x square minus 4x minus 1 is equal to 0. So this is how we will be getting the quadratic equations. So these are the formulas, and actually by now I think you have understood the concept behind it. We have understood lots of things, my dear student. By now we have understood quadratic equation, how to identify the quadratic equation. We have understood this. If you remember, all the conditions are on the variable, the power of the variable, not even variable, the power of the variable. The power of the variable should not be anywhere other than 2, and then non-negative. It has to be 2 basically. The degree of the variable, or the degree of the equation has to be 2. Okay, then how to solve the quadratic equation? To solve the quadratic equation means to find the roots of the quadratic equation. We know we have got factorization method. In that one, splitting the middle term also comes, and then we have got completing the square method. This also we have learnt. Okay, and then formula method. I hope you know the formula. Minus b plus minus root b square minus 4ac upon 2a. Okay, and then what we have understood is that the relation between sum of the roots and the equation, and the product of the roots and the equation. The relation is sum of the roots minus b upon a, and product of the root is equal to c upon a. Why do we require this? Basically, that if sometimes roots are given to us, then from the roots we can go and form the quadratic equation. How? Now whatever roots are given to us, we will find the sum of the roots, we will find the product of the roots, and then substitute that in this formula. Alpha plus beta over here and alpha into beta over here. Okay, my dear students, so with this we have completed a major chunk, and now few more questions. 5th, 6th, 7th. We shall try to complete this also. These are important questions. Sum of the roots of a quadratic equation is double their product. Now here they have told, they have given a relation. They have given a relation. Sum of the roots of a quadratic equation is double their product. See, try to understand, my dear students, what they have given by now. See, sum of the where am I? Sum of the roots of a quadratic equation is double the product. Means what they are asking you to do, is that, I don't know what do I do. Sum of the root is double their product. Sum of the root is equal to double their product. It is like this. This sum of the root is equal to double their product. This is what they have given you. Find k if the equation is this. This is the equation. What is this? X square minus 4kx plus k plus 3 is equal to 0. Okay. But what we have to do, see, normally what happens in the equation, they will be giving you the relation between the sum of the roots. Some relation between some information regarding the sum of the roots and the product of the roots. That is of the question. And you know that the relation between the sum of the roots and the equation. See, I'll tell you. See here in this question, sum of the roots of a quadratic equation is double of the roots. Find k if the equation. Now the equation is the given quadratic equation is what? So what is the given quadratic equation? X square minus 4kx plus k plus 3 is equal to 0. This is the given quadratic equation where a is equal to this, b is equal to this, c is equal to this. So you will just comparing with the general form. What is the general form? Ax square plus bx plus c is equal to 0. You will get a is equal to what? 1. B is equal to what? Minus 4k. C is equal to what? K plus 3. Are you getting this? Now from this equation you will get the values of, let alpha and beta be the roots. Therefore, now alpha plus beta is equal to what? Minus b upon a. You know this is by the formula. Minus of the formula minus. B is minus 4k, A is 1. This will become minus minus plus 4k. Now this is by, you have got by formula, and alpha into beta is equal to C upon A. C is k plus 3 upon A is 1. So this is going to be k plus 3. Now these are the values of alpha plus beta and alpha into beta according to your calculation. But now they have given, what they have given, sum of the roots is double their product. Sum of the root is double their product, means, but sum of the root is double their product is given. Means what? This alpha plus beta 4k is double product. Double the product means k plus 3. Solve this, you will get the value of k. Finish. Are you getting? So 2 I can directly bring it over here because 2 is multiplying with the bracket. I will get 2k is equal to k plus 3. K comes over here, 2k minus k is equal to 3. For k is equal to 3. This is the value of k. Finish. See, that's what I am telling. In one part, you will have to find alpha plus beta and alpha into beta according to the equation by the formula minus b upon a and c upon a. You will get the relation between, you will get the values of alpha plus beta and alpha into beta from here. And in the second part, they will give you some sort of relation, some sort of information. Not necessarily relation between alpha plus beta and alpha into beta only. This some information they will be giving you, and you have to link this information with this. These are the two different parts. Okay, my dear student, let's go to the question number 6. Question number 6 will take some time. Question number 6 will take some time. It requires some amount of basics. Question number 6 I'll do later, my dear students. We have finished off with 1. This is all we have finished. Question number 6 will definitely require some basics. This we can finish. Question number 7. Sorry. See, in question number 7, what they have done is that the roots of each of the following quadratic equations are real and equal. The roots are real and equal. This is again one more different question and very important. They have given you the information, and the information is the roots are real and equal. See, when roots are real and equal, what does that mean? If the roots are real and equal, means the discriminant is going to be equal to 0, exactly equal to 0. And that's what you have to use. That is the information that they have given. Now they call it, the equation is what? 3y square minus ky plus 12 is equal to 0. This is what they have given you. So now you will tell, comparing with ay square plus by plus c is equal to 0. You will get a is equal to 3, b is equal to minus k, c is equal to 12. Fine. So now you will get discriminant. B square minus 4ac. What will be b square? Minus k square minus 4 of the formula into a is 3 into c is 12. So you will get discriminant is equal to minus k square will be k square minus 4 3s are 12, 12 12s are 144. This is what you have got. But since the roots are real and equal, this is given, the roots are real and equal is given, therefore delta or the discriminant is exactly equal to 0. It has to be equal to 0. Therefore from 1 and 2 you will get k square minus 144 is equal to 0. That's all. Now you have to solve this. You can solve it by factorization method. K square minus 144 will be 12 square is equal to 0. K plus 12, k minus 12 is equal to 0, because we know that a minus b into a plus b is equal to a square minus b square. By this formula we have got this. So this will be k plus 12 is equal to 0, or k minus 12 is equal to 0. Therefore k is equal to minus 12, or k is equal to plus 2. These are the values of k. Okay. So with this we have finished with question number 7, and now only question number 7 ka second question is remaining. Do I require another page? It's okay. Second question. In second question, it is basically simple, but the thing is that they have given the question in somewhat complex form. Kx x minus 2 plus 6. Now if you will open this bracket, kx into x will give you kx square plus minus minus kx into 2 will give you 2kx plus 6 is equal to 0. Now same thing, this will be your a, this will be your b, and this will be your c. Same thing, comparing with a x square plus bx plus c is equal to 0. What is your a? K. What is your b? Minus 2k. What is your c? 6. Fine. This is your a, b and c. So you will get discriminant. B square is minus 2k the whole square minus 4 into a is k into c is 6. Fine. Minus 2k the whole square, b square minus 4 by formula k, and then c6. That's all. The discriminant is equal. This will become plus 4k square minus 4 6 the 24k. This is what you have got. But the roots are real and equal. This is given. Therefore, discriminant has to be equal to 0. Therefore, from 1 and 2, what do we get? 4k square minus 24k is equal to 0. We can reduce this. We can find the common factor will be 4k. K will go outside. This will be 6. Right? 4k, 4, 4, 1k, k, 4, 6, that's all, is equal to 0. Therefore, 4k is equal to 0 or k minus 6 is equal to 0. Therefore, k is equal to 0 or k is equal to 6. These are the two values of k, 0 or 6. So with this we have with this it can become, just a minute, my dear student, the question is something, the roots of each of the particular division are real and equal. Find the one thing is there, my dear students, one thing is there. Here some, see my dear students, this is a tricky question. When this comes, you have to once see if here in this case it was very easy, minus 12 plus 12. You substitute the values of minus 12 over here and this will become 0. You substitute the value of 12 over here and this will become 0. Then k is right. Coming over here, kx, x minus 2 plus 6 is equal to 0. See, if you substitute k is equal to 6, k is equal to 6 if you substitute. This will become a quadratic equation. 6x square minus 12x plus 6. This is become a quadratic equation which you can divide throughout by 6. You will get x square minus 2x plus 1 is equal to 0. This will be a quadratic equation that you will be getting, and because the value of k is substituted as 6. But same if supposing I substitute the value of k is equal to 0, it will become 0x into x minus 2 plus 6 is equal to 0. So this whole thing will become 0 plus 6 is equal to 0, and then 6 is equal to 0, which is nonsense. Which is nonsense. So this here, this is tricky. That's why actually whenever you get this type of solutions, once you will have to pay attention on the question. So here, since k is equal to 0, will turn the equation non-valid. Therefore, k cannot be equal to 0. K is equal to 6. Only 6. This is very important, my dear students. Sometimes some tricks they play and then you have to be careful over there. Okay, my dear students, with this we have finished with question number 7, and only one will be remaining, that is question number 6, and that requires some amount of basics. That's why I have kept that aloof. Once we finish that, then I think then we will be entering into word problems. Okay, my dear students. Problem set also is there. Okay. So with this we finish today's lecture, my dear students. I hope you have understood the lecture. Thank you very much. Take care. Stay home, stay calm, stay safe, and most important, stay happy. Okay, my dear students, take care. Love you all.